Okay, this is a quick review of what we did today in class, and hopefully will help you all with the homework. The first thing we did is, I had you guys guess the number of dots inside this rectangle after your quiz on Monday, and we recorded two things when we went to graph these, and I'll use Brooke here, she's from 4th hour, as an example. She guessed 250. Well, I knew the answer was 160 dots inside. 1st hour had 133. And then I calculated the distance that Brooke's guess was away from the actual amount, 160. And that was 90. So we made a plot of all of our guesses as our x, and that distance from 160 as our y. So Brooke's entry would look like 250 and 90 for distance away. And we did that for everybody in the class, and then we graphed the results. And the results are shown on this graph. They're the black dots. Okay? And so you can see on this graph that 160 is right here. And I think Mike was exactly at 160. So that is his point. And then the y value represents how far away each other guess is. And so the graph of this, we put in the green line there, shows the actual graph of the equation that models all of your guesses. That is the absolute value of x minus 160. Again, y is representing the distance your guess is from 160. And to find distance from something, remember, you just subtract the two values, and we use absolute value because distance is not negative. Okay, so that was the start of our discussion about absolute values. And then, so this is section 2.5 that we're discussing, and here's what we are trying to accomplish. And I think most of everybody here has these in their notes, and you can just pause the video if you need to write them down. But what we focused on today was finding the vertex and plotting points to graph these absolute value functions. We also hoped to write two equations by limiting the range, but we didn't get to that. And we didn't get to C. C is a completely separate section. But we did use D today. And I may have to shoot a video of exactly how to do that as well. So let's cover A in these notes. And I'll try to do it quickly so you don't have a half-hour video. Okay. Some things that we need to note. Okay, the first thing, they don't prove it or anything, and that's okay. It tells us the vertex of any absolute value function written like this. Let me write it in a form you'll see more frequently. Instead of ABS, we use the absolute value symbols. Okay. The vertex of this is always located at the opposite of whatever B over M is, that ratio, comma, C. Okay, this equation is very similar to y equals mx plus b, but it's got the absolute values around the mx plus b. And then we have that c term that's kind of dangling off to the outside. And so if we look at the problem that is presented or graphed right here, we can see it has an m value of 1, a b value of 3, and a c value of -2. And so when we look for its vertex, we go the opposite of b, which is 3, over m, which is 1, and then our comma. For our y coordinate, we use c, which is -2 in this case. So our vertex is at -3, -2. And you can see that's right there. That is the vertex, in case I forgot to mention that. Okay, that's that lowest point in this case of this absolute value function. Okay, some other things to point out is this line has an axis of symmetry, or this equation or graph does, and that axis of symmetry is right there. And that's a line at which you could fold this paper on, and the two sections or two branches of the graph would line up with each other. This is a vertical line, so it does have an equation. Its equation is x equals -3. Domain and range. For domain, we look at the x-axis here, and we see it goes forever up here to the left and up, but we're concerned about the x, so it goes left and forever right. So our domain is going to be all real numbers. It covers everything left and right, and obviously everything in between is graphed on the green line. The range, it does have a lowest y value down here at -2, but it goes up and up forever. So our range is all y values that are greater than or equal to -2. Some other things, this point down here not only is called the vertex, it is also a minimum of this function. It's the lowest point the function goes to. This function does not have a maximum because it goes up forever. So that's kind of it in a nutshell, and then on this slide we will go through all the steps on how you're going to graph these things by yourself. Okay, so I'm going to write it the way our book would present it. First thing I would do is compare it to our standard model of absolute value functions, and I would determine what m, b, and c are. M is 2, b is -5, and there is nothing here, so c must be 0. Next, I'd use the formula for counting vertex, -b over m, c. I'd plug in my numbers. I've got the opposite of b, which is already a -5, over m, which is 2, and c is 0. So notice, pay special attention, we want the opposite of what b is, so it's a negative of a negative. So our vertex is at 5/2, 0. And because we're looking for a point, not thinking of 5/2 as a slope, it certainly isn't, it's an x-coordinate. We might want to write that in decimal form, or you can think of it as 2.5. But 2.50 is our vertex. So we know where that minimum is, or if this absolute value function was upside down, maximum is. That's that point where the two rays meet each other. Okay. Next, to find a point on either side of that vertex, we can just grab an x value and plug it into our equation. A good choice for x, we want it to be left of the 2.5, so I'm going to choose 0 for x. And so if we plug 0 into the absolute value, we get 2 times 0, which is 0 minus 5. We get the absolute value of -5, which is just 5. So 0, 5 is another point, it's right there, on our graph. Because the first point we found was our vertex, this ray must go straight through that point coming from the vertex. I'm going to redraw that with a straight line tool here, hopefully. Put an arrow on it, and let's make it green. See how we do. There we go, that's pretty good. Now the nice thing is, because we've talked about the symmetry already, is we don't really have to put another value in for x if we want to find another point. We can say, well, this red point must have another symmetric point across from it. It's 2.5 away from that axis of symmetry, so we'll go 2.5 to the right, and there's another point. That's on the other ray. We'll draw that one in. And so that is our absolute value function graphed. We could answer a ton of questions about this at this point. Let's just list a few of those things. I'll cut a few of these things out so we got some room to mark stuff. Not sure why that all came back, but let's get rid of some of that. There we go. Okay, let's first answer this one. Domain goes forever left and right, all real numbers. Range, lowest point it goes to is y equals 0, and then it goes up. So it's all y values that are greater than or equal to 0. Okay. Is it a function? Yes, because it passes the vertical line test. Vertex, we've already found that. That's at 2.50. It has a minimum. The minimum of the function is the lowest y value it goes to. so we'd say its minimum is 0, and that occurs at x equals 2.5. Okay. And I think that covers it. Let's take a look at another one. This one is y equals that negative sign out in front of the absolute value, x plus 1 minus 2. Vertex, negative b over m, c. Some students had a little tough time with this negative sign out there threw them, but if you think about our standard form, it's mx plus b plus c. The m is what's in front of the x, inside that absolute value, so m is still 1, and b right there is clearly 1, so it's going to be at 1 over 1, but the opposite of that, negative 1. Okay, so let me write those down again so you can see them. M is just 1, b is just 1, and so negative b over m is negative 1 over 1, which is negative 1. And the c value is always the easy one, negative 2. So there's our vertex, negative 1, negative 2, right? Oops, cancel that. Negative 1, negative 2, right there. I like to draw my axis of symmetry at this point. It's going to help me out. I can pick now any value that I would like to for x, except the one value you do not want to pick is, let me rewrite this so we can see it. The one value you do not want to pick is negative 1 for x. And the reason you don't want to pick negative 1 is you already know what happens when x is negative 1. You get negative 2. So let's plug in something to the right of it. Let's plug in 3. That's a good distance away. So we'll go x equals 3. And we'll plug a 3 in. We'll let the math do its thing. Oops, erase that. Okay. Notice we get the opposite of the absolute value of 4. Well, the absolute value of 4 is 4, but we got a minus sign in front of that. And so, negative 6. So we plugged in 3, and out came negative 6. So if we mark that on our graph, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, it becomes apparent that this one opens downward. And there is the first array. Again, using symmetry to get a point on the left-hand side, we can see this distance from axis of symmetry is 4 units. So we just have to count over 1, 2, 3, 4 at the same y position. There is a point on the left-hand side of our vertex. And there's our graph. Okay. I'll leave it up to you for domain and range. It's obviously a function, passes the vertical line test. This thing, in this case though, it's not called a minimum, this would be a maximum of the function. Okay. I think that's everything that you need to know. We gave you guys slightly different homework problems to work on. But I will find, well, hopefully you all got that. Let me pause real quick and I'll believe it's page 89. Each class was different. 36 through 41. But if you do a group in that section, we'll cover questions over that tomorrow and you should be fine.